Good day, everybody. And once again, we are back together. All right, so we are looking at 5.3. In our previous video, we were looking at 5.2. You can see we still have those answers. So please, if you haven't watched that, go and watch that. If you have not subscribed, what have you been waiting for? Let's dive into the question. All right, so let's look at the first thing there. They say in the diagram below, we've got D and E, which are midpoints, okay, of X and Y, right, and Y and X and Z respectively. So this point over here and that point over there are the midpoints. So that's why XE would be equal to EZ, okay. But similarly, it means that dx would be equal to dy. Okay, right. So before I even continue, all right, I hope that you can already see that that's an application of the midpoint theorem. And what does the midpoint theorem simply state? That if a line bisects two sides of a triangle, like we do here. So if a line bisects two sides of a triangle, then it must be parallel to the third side. Okay, right. So in this case, it means that we can then conclude that DE must be parallel to XY. I hope that you can see that, ladies and gents. Very important. And then, so they say F is the midpoint, or rather F is a point of intersection of DZ and EY. We can see that. And they are giving us all of the dimensions. They say that DE is 19 millimeters. They said ZDE is 40 and YED is 46. All right, now in this case, we've got all the other angles that are unknown. So I can already actually state that it means that angle EYZ, so EYZ, that is that angle alpha over there, I can already say, well, this is 46 degrees. I know that we haven't started answering the questions, right? Why is that? Because those would be alternating angles, right? So those would be alternate angles. And then again, if I look at beta, there's our set of alternate angles again. So in that case, it means that beta would be equal to 40 degrees, right? It already tells you that those are similar triangles, right? That is DFE as well as YFZ. Okay, right. Now they say to us, calculate stating reasons the length of YZ. Okay, so we are looking for the length of YZ. Now, guys, I want you to please note this. Okay, so if I'm looking at the midpoint theorem, it simply says if I were to take any side, now I want you to think about it. If I take xd divided by xy, right? xy would be twice xd. Why is that? If I said, well, let's just say for argument's sake, this is 3 meters, right? That is xd is 3 meters. Then what would that make yd? That would also be 3 meters. But then what would be xy? That would be 6 meters. So meaning that the side of the smaller triangle will be 2 times the side of the bigger triangle, right? Well, where am I going with that? That is, if I look at xy, all right, that will be equal to 2 times DE. Why? Again, you're looking at the side of a smaller triangle and the side of the bigger triangle. So we said the side of the bigger triangle will be twice that of the smaller triangle, right? And in this case, why is that? We call this the midpoint theorem. Okay, that's the midpoint theorem. And so what that means is that YZ would be 2 times 19 millimeters Okay, and so that would be 38 millimeters. All right, that's the value of xy. Then let's go for the next part. They say to us the size of alpha. Okay, by the way, we were meant to actually state, but we'll do that in the next one. Okay, so we want to find out what is the size of alpha, but we've already found that, isn't it, ladies and gents? We said, well, it means that angle DE is equal to, angle, what did I say? No, actually, side DE is parallel to YZ. Why is that? In this case, because of the midpoint theorem. Okay? Midpoint theorem. Oops. So that's the midpoint theorem. Remember, we said that if a side bisects two sides of a triangle, then it must be parallel to the third side of a triangle, right? So in this case, we're going to say angle alpha. Therefore, angle alpha, right, which is this guy, is equal to angle DEY, which is equal to 46 degrees. And why is that? Because those are alternating angles. Right, and then finally they say find the size of angle YFZ, which is this guy over here. Right? So, firstly, in fact, let's write it over there, 5.3.3. So, firstly, we need to make an announcement. We already know that alpha is 46 degrees, but beta is also equal to angle DEZ. DEZ, which is 40 degrees. But why is that? Because they are alternating angles, right? So those would be alternating angles. And so, ladies and gents, in triangle YFZ, okay, we know that angle alpha plus beta plus the angle they are looking for, YFZ, is equal to 180 degrees. Remember, these are the interior angles of a triangle. Okay? Right, you need to state the reason all the time, ladies and gents. And so, just to note there for you, we've got 46 plus 40 plus YFZ, that's 180. And so YFZ would be equal to 180 minus 46 plus 40. Okay, so that would be 86. So that would give us 94 degrees, I think. Okay, that's 180 minus 86. Yeah, we got 94 degrees. Right, ladies and gents, that is how the cookie crumbles, and I'm going to be seeing you again in the next question. I really hope that you understand this section. But as I said, with all the sections that are not necessarily there as yet, I'm still going to give you some great content when it comes to all of these sections. For now, I'll see you guys next time. Sharp.